Hello everyone, myself Hans. Today we are going to solve the problem of integrated calculus of UPSC 2016 question from beta and gamma function. Here in the question, evaluate the integral 0 to 1 and cube root of cube x log 1 by x dx. Let's solve the problem. The problem is based on beta and gamma function. Given integral is I is equal to integral limit is 0 to 1 and here is cube of root x log 1 by x dx, and we can also write that is integral limit is 0 to 1 and this is written as x to power 1 by 3 to log 1 by x to power 1 by 3 dx, and further we have to use beta and gamma function to solve the given problem. Let log of 1 by x is equal to y, and from here we can also write it, this is log of x to power minus 1 is equal to y, and using the property of log we can also write minus of log x is equal to y, and from here this is written as log x is equal to minus of y and x is equal to e to the power of minus y, and from here we have to find the value of dx is equal to differentiating e to the power minus y with respect to dx, that is minus of e to the power minus y dy, and we have to further we have to change the limit. When we have to put x is equal to 0, we get y is equal to infinity, and when we get x is equal to 1 and x is equal to 1, we get y is equal to 0. So we have to first change the limit also, and this is given by integral limit is 0 to 1, and in place of x we have to write here e to the power of minus y, e to the power of minus y to power 1 by 3 into, in place of log 1 by x we have to put y, this is given by y to power 1 by 3, and in place of dx we have to write this is minus of e to the power of minus y dy, and minus is taken into outside, this is written as minus of 0 to, we have to change the limit here, that is when we have to put x is equal to 0 we get infinity, and we have to put x is equal to 1 we get 0. This is infinity to 0, and we can write here infinity to 0, and from here e to the power of one second we have to multiply, this is given by minus of y multiplied with 1 by 3, this is given by minus of y by 3, and here is y to the power of 1 by 3 and dy 1 by 3 and dy, once again power minus y and is already present here, e to the power of minus y dy, and further we have to write this is I is equal to integral limit we have to change, this is 0 to infinity, minus is removed here, this is written as 0 to infinity, and y to the power of 1 by 3 and e to the power of minus y by 3, this is minus y by 3 and e to the power of minus y. We have to add, taking LCM, that is written as 3 on 3, that is minus of 3, and this is minus of 4y upon 3. We have to write here e to the power of minus 4y upon 3, and this is dy, and further we can also let here, that is 4y upon 3 is equal to t, and from here we can also find 4 upon 3 dy is equal to dt, and we have to replace dy. This is given by dy is equal to 3 upon 4 dt, and also we have to put the value of y from here. This is given by y is equal to 3 by 4 into t. Here we have to put, and we have to change the limit also, nothing to effect. So we have to write here integral limit is 0 to infinity, and in place of y we have to put 3 by 4 into t power 1 by 3, and e to the power of minus 4y by 3 we have to take, let t, this is equal to t, so we have to put here minus of t. In place of dy we have to put 3 by 4 into dt, and further we have to write also, this is given by I is equal to integral limit is 0 to infinity, and from here this is 3 by 4 की power 1 by 3 and t की power 1 by 3, and this is written as e to the power of minus t, and here is 3 into 3 by 4 dt is already present. Further we can also write the integral is equal to 0 to infinity, and from here 3 by 4 की power 1 by 3 and 3 by 4 की power 1. We have to add here and take it into outside. This is given by 3 by 4 की power 1 by 3 plus of 1. This is written as 4 by 3. 3 on 3, this is 4 by 3. And integral limit is 0 to infinity, and here is remaining t to the power of 1 by 3 and e to the power of minus t dt. Further we have to know that, or we can also write, this is given by 3 by 4 की power 4 by 3, and integral limit is 0 to infinity, and e to the power of minus t and t to the power of 1 by 4 minus of 1 dt. When we have to take LCM, once again we can also write e to the t की power 1 by 3. This is written as 3 by 4, once again 4 by 3 minus of 1. When we have to taking LCM, this is 1 by 3, we get t की power 1 by 3, and using the formula that is given by gamma n is equal to 0 to infinity, and this is e की power minus of t and t की power of n minus 1 dt. We write gamma n, so we have to use this formula. This is given by I is equal to 3 by 4 whole power 4 by 3, and in place of we have to write gamma of 4 by 3, and we can also write gamma of 4 by 3. This is given by 3 by 4 की whole power 4 by 3, and gamma 4 by 3 is written as 1 by 3 plus of 1, and this is 3 on 3, 3 1 plus 4, this is 4 by 3, and using the formula gamma n plus of 1 is written as n gamma n. So we have to write here integral I is equal to 3 by 4 की power 4 by 3, and we have to write here 1 by 3 into gamma 1 by 3. 3 1 ja 3, once again 4 by 3, 3 1 ja 3, and plus 1 is 4 by 3, and further this is the required solution. If you can also write, this is gamma of 1 by 3 is written as 1 by 2 plus of 1. 2 1 are 2, that is 3 by 2. This is the required solution of the given problem. UPSC asked in 2016 for 10 marks. Thank you class and thank you for watching.